This is a video on how to use the ideal gas law in stoichiometry problems. So we're not going to go over many stoichiometry. You should know how to do them. We're just going to look at the ideal gas law and give one example. So the ideal gas law is PV equal nRT. Now, one thing that should be noted here, and you'll hear me saying this all the time, the ideal gas law is for gases. You can't use it with a liquid or solid. I don't know why people try, but they do. So in this, P is equal to pressure, and it's got to be given in atmospheres. So we have a bunch of units that we can use, and the conversions you're not expected to memorize. They're given in the book, but units are given on the handout are in kilopascal, pascal, torr, which is equal to millimeter of mercury, PSI, and bar, kilobar, etc. So you need to be able to do conversions as needed. The volume of a gas is the volume of the container, and it's got to be in liters. Gas always fills up the container it's in. T is the temperature. I'll shorten it to temp, and it's got to be in Kelvin. So the rule is the temperature in Kelvin is equal to the temperature in Celsius plus 273.15. That's the rule for converting that. We don't ask temperatures in Fahrenheit, but if it was, you'd have to convert it into Kelvin. And N is the moles of gas. So this is where we're going to use our stoichiometry here. Sometimes we use it to get moles, etc. Okay? So you got to watch how that's used. And then finally, R is a gas constant. I'll put it in red up here. R is equal to 0.08206 liter atmospheres per mole Kelvin. Okay, so this is the gas law, and you're going to use it to answer questions. So I'm going to erase this. I'm assuming you have it written down on paper so you can follow the video afterwards or as I go. So let me clear, and we'll work from there. So we're going to expect you to solve for any one of these variables: the pressure, the volume, and the temperature of a gas. You could be required to calculate one of these from the gas law. So you will always have R. R is going to be given. And you usually get N from the stoichiometry. So this requires careful reading of, careful reading of the problem. So I'm going to write out a problem here, and then we'll write the equation, reaction, and do the problem. Okay, so here's my problem as stated. 30 grams of aluminum react with H2SO4 to form what volume of H2 gas at 20 degrees at 0.98 atmosphere. So I write down what I know, 30 grams of aluminum. This implies I have plenty of H2SO4, so don't worry about that. It doesn't ask anything about the aluminum sulfate. It does give me the temperature equal 20 degrees Celsius, pressure equal 0.98 atmospheres, and it asked for the V. Okay, now we need to figure out how to proceed. Okay, so when I look at this, I notice that I can't quite use the PV equal nRT rule because I don't have N. So that's what I got to get, and I'll get it from here. So I take my 30 grams of aluminum, and the molar mass of aluminum is 26.98 grams of aluminum per mole of aluminum. And now I note that there's 2 moles of aluminum per 6 moles of hydrogen. So multiply by 2 moles aluminum, 6 moles of hydrogen. And note the gas law, this is hydrogen gas, and that's what I need. So I'll stop right there. And let me calculate that, and I get 3.33 moles of hydrogen. Okay, I'm going to have to erase some stuff. So, but that's the value I needed, 3.33 moles of gas. Hydrogen's my gas. Let me erase. Okay, continuing onward, I don't have enough paper. I note that the pressure is in atmospheres, the temperature is in Celsius, so I've got to convert that. T Kelvin equal T Celsius plus 273, so it's 20 plus 273.15, which is 293 Kelvin. I will have 3 sig figs in this because I started with this precision right here. So I'll end up with that precision. So then PV equal nRT. So the volume equal nRT over P, which is equal to, I barely have enough room, 3.33 moles, 0.08206 liter atmospheres per mole Kelvin times the temperature, 293 Kelvin. Wow, this is tight. Divided by the pressure, which is 0.98 atmospheres. My atmospheres go, my moles go, my kelvins go, and I have liters, which gives us, I'm going to put it in green down here at the very bottom, I get 82 liters, and I'm done. Okay, I'm going to talk some more. Let me erase all this. Okay, so part of the thing is you're going to be able to have to solve for the volume, temperature, or pressure of any gas. I can go from a gas to a gas, so I could have a lot of calculations here. One other thing you need to know is sometimes you'll see the symbol STP, that's standard temperature and pressure, which the temperature is 273.15 and the pressure is 1 atmosphere, exactly 1 atmosphere. So that's in a nutshell. We'll do a bunch of problems in class.